Hello everyone, my name is Jelani and welcome to my channel that is dedicated to helping you improve and succeed at CXC math. Now in today's video, we're going to be looking at some CSEC add math, and our topic for today is vectors. Our main objective, if you look just below, is position vectors. And the question we're interested in is the May-June 2018 paper 2, question 3 part C. So let's dive into this question here and see what's really going on. So they give us two vectors, OA equal 2i plus j and OB equal 3i minus 5j. And they ask us firstly to find the magnitude of vector AB. And you need to be careful here because they're asking for the magnitude of vector AB, but we weren't given AB at all. We were just given two position vectors. So we need to use our knowledge of position vectors to work out what the vector AB is. And then we could go on to find the magnitude of AB. So let's see how that's going to look. What you want to do is you want to draw up a kind of sketch, a very small, simple sketch to depict what the information they have, what is going on there. So it doesn't have to be too perfect, it's just a sketch. And here is our y-axis and this is our x-axis. And we want to get the position vector for OA. And we know that any position vector always starts from the origin and it goes to wherever that position vector is telling us. So they're saying 2 on the I or x-axis and 1 on the y. So we're looking at something here. This could be our first position vector. And our second position vector is 3 on the I or on the x and negative 5 on the y. So it may be somewhere around here. Now again, it doesn't have to be too perfect, it just needs to show what it is that they're giving us. And now our vector AB is what we call a displacement vector. And how you think about displacement vectors is you just think of yourself as walking along our position vectors. So if here is A and this is B, and we want to get from A to B, what we need to do is we need to walk backwards along this vector and then come forward on this vector. And once we do that, we'll have successfully walked from A all the way over to B, giving us vector AB. So that means if we want to figure out how to calculate vector AB, we could simply say this. We could say that AB, but what do we need to do? We need to go backwards. So we need to go from A to O. And then we need to go from O to B. But going from A to O, that was just the exact same length as OA, the vector that they gave us, but we just went in the opposite direction. So what we could say is that AO is the same as negative OA. So we just replace AO with negative OA. And now we could go ahead and substitute the information we have. Now we could substitute it in its I and J format like this, or we could substitute it in its column matrix format, which most people are a little more comfortable working with. We could substitute it like this. We could say, okay, this is 2 here, this is 1, plus 3, and negative 5. So now we could simply just add these two vectors. We have negative 2 plus 3 and 1 minus 5. And that gives us negative 5 and negative 4. And when this negative sign on the outside interacts with the elements on the inside, we get our vector AB to be this. We get negative 5 and positive 4 as our vector AB. Now, look at that. We just found our vector AB. But what we need, what the question is asking us for, is the magnitude of AB. So we're not finished yet. So AB is equal to negative 5 and 4. Now we need to find the magnitude of AB. And to get the magnitude of any vector, we take the root of the x component squared plus the y component squared. So the x component is negative 5. So we want to square this. Plus the y component is positive 4 that we want to square as well. And then we're going to square root that answer. So negative 5 squared is simply 25. And we add in 4 squared, which is 16. And what do we get here? We get 6 and 5 is 11. 2 and 1 is 3. We get square root of 41. Now we could leave our answer like this, or we could work it out with our calculator, and we get square root of 41 to equal 6.4. And there you have it. We've just used our knowledge of position vectors to find the magnitude of this displacement vector AB. Just to go back here, just to recap everything that we did, just want to point out that we made a switch in the working. We use the column matrix format of working, just because most people might be more accustomed to that because you do it in the regular math syllabus. And the I and J format, while it is important, you could also interchange between it so long as the question isn't being too specific. So that's why I use this column matrix format here to work with. And just to recap everything that we did, we took the two position vectors that they gave us. We drew a small sketch to see what was going on, and we created our displacement vector. We calculated our displacement vector, and then we moved on to find the magnitude of our displacement vector by finding the square root of the x component squared plus the y component squared. And we got 6.4. So if you made it this far in the video, first of all, I'd just like to say thanks for sticking around. I hope that you're able to learn something from it, and I hope that you found the video beneficial. If you did, you could consider giving the video a like. And if you'd like to see more videos like these, you could also consider subscribing to my channel to see more. I'm also on Instagram. You could check down below there if you want to follow me on Instagram as well. And just one last thing, I also post videos on CSEC math as well. So if you think that might be beneficial, you could stick around to see some of those videos as well. Thanks again, and I'll see you in the next video.